Hi, Santiago here. Let's learn how to model from Rhino to Grasshopper while we learn modeling in Grasshopper for complete beginners. Let's do this. I recommend you working through this process step by step. Although you will have access to the final file, it's important to understand the role of each element. Missing just one component can cause the whole definition to fail. In this video, we will introduce you to Grasshopper by performing simple commands from different categories. This will give you an overview of the categories in Grasshopper. Take the time to explore all the tabs and groups so you can familiarize yourself with them. So let's open Rhino and get started with Grasshopper. So first of all, we'll want to set the element in Grasshopper. So we select the element in Rhino and we add a BRep component and we right click over it and set one BRep. So we have it. After that, we want to work with the elements, the components that are in the transform tab. We'll open it a little bit so we can see it. You can see that there are a lot of tabs, a lot of elements or groups, and also components inside of them. In this case, we'll work in the 9th tab, that is transform. For us in Rhino, it's like the first command, but in this case, it's something that it's a bit far away from the basic elements. And then in the Euclidean group, we'll work with mirror, with move, with rotate, and also with these two of affine, scale and scale in non-uniformly. So let's do this first. Let's try to move it. We add a move component. We connect the BRep to the geometry. And we can see that it's moving, but it's moving to the Z axis. We don't want that. We want that to move it to the Y axis. So we need to first add a unit Y component and connect it to motion. You can see here that it's moving, but it's moving really slow. So we need to add a number slider. You can add it by clicking on number slider, or easily, if you want to set already the data that you want to configure in that number slider, you just add, for example, -10, lesser than, symbol, and then 10. You can see that the number slider is being configured. You click in enter and you can see we have configured it. After that, we connect that number slider to the factor, and now you can see we can move our element in the Y axis. Now let's rotate it. Let's add the rotate component and let's connect the BRep. After that, we need to set the angle. So we need to add a radians component, that is the one that changed the data to radians and the angle of rotation, and also a number slider from 0 to 360. Let's connect it, and you can see that it's rotating, but the rotation is taking reference from the 0.0.0 point as the center of the rotation. We need to change that. To do that, we add an area component to reference the centroid of our element, but we also want to define the direction of the rotation. In this case, we want to make an XY plane. Let's connect the centroid to the origin of the XY plane. And after that, let's connect the plane output of XY plane component to the plane input of rotate. You can see now that we rotate and it's rotating by reference of that plane. If we want to change that, you can also add, for example, a YC plane and do the same. Connect the center to the origin, the plane to the plane, and see how it rotates to another direction. After that, let's add a mirror component. For example, now I'm going to take it from here. Let's connect the BRep to the geometry. You can see that it's rotating in the reference of the X axis, but we want to make it to the Z axis. After connecting the BRep to the geometry input, we just need to set the plane where it will be mirrored. For example, in this case will be an XY plane. We connect this plane to the plane input, and we can see now that it's being mirrored by referencing the XY plane. If you change this one, it will also change the direction of the mirror. Then let's scale it. Let's add the component scale in the affine group. Let's connect the BRep to the geometry. The center, we can use already the area centroid output. And you can set the factor. For example, we can add a number slider from 0 to 2.00. Taking count that when you add a 0.0, it would also change the numerical value that it's being configured in the number slider. Let's connect the number slider to the factor and let's start to play with it. Let's click on it and let's see how does it change. We can see how it's been uniformly scaled. Let's hide all this data so we don't get a little bit lost with it. And finally, let's scale not uniformly. We add the scale non-uniformly component. We connect the BRep to this geometry. We can also add the area centroid to the plane. And let's copy the number slider. Let's paste it. And let's play with the configuration according to the axis that you want to scale. For example, let's connect it to the X. You can see that it's only being scaled by one direction. You can also connect it to the other one, and you can see that it's being scaled in two directions. If you put it in 3, it's the same as the scale that we have made before. So you can play with it and see how does it change, and you can modify it. This is a really useful tool if you want to edit in a non-uniformly way a shape of something you're modeling. So now let's take some information from the curve. Here it seems simple, but in complex structures, it's vital to understand what information we want to use of a simple shape that could be, for example, a profile of a complex roof. Let's set it on Grasshopper. Let's add a curve component in Grasshopper. We have already selected in Rhino. Right-click over the component in Grasshopper and set one curve. So let's subtract some information. For example, let's take the endpoints of this curve. In this case, you can see that information is in the curve tab, that it's the fifth one, and you can find it in division and in analysis. We're going to work in the components located in this tab. You can explore the other ones because they are a lot, and all of them are really useful. So let's add endpoints. Let's place it, and let's connect the curve to the endpoints input. You can see that it's showing us that he's only taking the points from the start and the end of the curve. And you can also, for example, add a point component and connect it to one and just select one of them. After that, let's find the middle of the curve. We add curve middle. You can write it or just find it in the analysis group. Let's connect the curve, and you can see that it's showing us the middle of the curve. Let's now find the control points that are the ones that create the shape. So let's type control points. Let's connect the curve in the input, and you can see now that he's showing us the control points, and if we select also in Rhino, you can verify that the information is correct. Let's find the length of the curve. Let's type length, connect the curve output to the curve input, and if you place the cursor over the length, and you can see that the value is 35.8. This can be really useful if you want to set this information. And after that, we can use another one that it's in division group, that it's divide curve. We add it, we connect the curve output to the curve input, and let's add a number slider from 0 to 10 and connect this number slider to the count. Let's hide the other ones so we don't get confused of what we're doing. And you can see here that if we increase the value, it's dividing it equally in the points that we set. For example, here 1, 2, 3, 4, 5, 6, 7. It's divided in 7 elements. This can be really useful if we're trying to construct a profile of a structure. It seems a little bit like numb, like simple, like basic, but trust me that this is going to be really useful in the future when you are trying to think on something more complex. I forgot to tell you. When you're adding these elements, don't forget you will find these elements in the params tab. That is the first one. Here's the geometry that you can construct or you can connect and set from Rhino. So it's really useful that you can see that all these elements can be brought and create in Grasshopper. So we set the curve, we go to geometry and put the curve component. We right click over it and set one curve. And then we search for the extend curve. That is also in the curve component. We go to the util group. We go to extend component, extend curve. We click on it. We connect the curve. We add the extend curve. We place the number slider and we can see that when we place this one in the start input, it doesn't work. It isn't showing anything. So we need to give information also in the end input. For example, we can make it, maybe place this as 0, connect the end, and works. It's kind of funny because we haven't set it data to this slider. You can see in the red curve what we are modifying from our curve. You can see that we can increase uniformly and also connect it individually and place with each one. After that, we are going to use another one in the util that is explode. Let's add it. We connect the curve output to the curve input, and we can see that we selected, but doesn't change anything. We're just seeing the elements and also the points. You can see now that we, for example, have the segments and also the vertices. What happens here? So nothing changed, but really a lot changed. Let's add a crucial component in understanding the way Grasshopper works. List item. Grasshopper, it's really a process of the data lists and how do we set the ones that we want to use. Let's add the components and connect these segments to the list input. Here now you can see that is selecting just one of them. Is because he's gaining the information of the explosion, and in the index you can see that is set to 0. So he's selecting the segment number 0. We can do the same with the vertices. He's just selecting the first vertex. If you want, for example, to select the last one, you can set the integer to -1. It can work in the segment and in the vertex. And also, if you want, for example, we can click on it. We have 4 local values. We have 4 values. So we add a slider from 0 to 4, and we can connect it to the index and play with which one of the elements are we selected. Also works with the vertices. And the sync, as I told you before, this seems kind of numb, but this information is really useful because you need to understand how the 3D is being processed and how this list of items changing and selecting are the ways we are creating our structures, our models, and everything in Grasshopper. This is crucial. After that, let's see the data we can extract from this surface. So let's go to Parents, go to Geometry, and search for the surface component. Let's right click over it, set one surface, and let's add a contour. So first we're going to work in the intersect category tab and mathematical category. We click on contour, we add it, and we connect the surface to the shape. You can see right now that nothing happens, but we need to set the distance between the elements. We set the number slider from 0 to 10, we connect it to the distance, and you can see when we add a value, because here is not a value, that it's creating the contours of our surface. If we want, for example, to change the direction of the contours, we just add a unit Y component. This can be found in the Vector tab on Vector group. Unit X, unit Y, and unit Z. You just connect the output in the direction input, and you can see now that we have changed the direction of the contours we were modeling. Then let's triangulate the structure. For that, we just click on 3 remesh. This one can be found in the Mesh tab in the triangulation group. You click on 3 remesh, you place it, we connect the surface to the geometry, and you can see that has already modeled our triangles in the structure. If you want to change, for example, the distance of the triangles, you can set the length of the triangles. For example, this case is 0, so it's not going to work, but let's wait till each charges and see how does the triangles change. In this case, for example, you can see that they're incredibly little because he's trying to understand that. But let's put 2 in the number slider. You can see that we can configure and see how maybe the structure, maybe the body, the form of our dome is being shaped by triangles. Also, we can do that with quad remesh, that is also in triangulation. In the Mesh tab, quad remesh. We connect the surface to the geometry, and you can see also we have a lot of little squares in it. We just need to add a number slider from 0 to 500 and connect it, for example, let's put it 20 and connect it to the settings. You can see now that it's more simpler dome, but we can set, for example, 250 and see how the dome gets a little bit more complex, but more useful as a dome. After that, for example, we can take that information of the mesh we have made. We just add a deconstruct mesh, we connect it, and we can see that now he takes us all these points from the dome that we are making. This can be really useful if we want to set the profiles to connect the elements that are being shown here. You can also, as we do before, add a list item and set, for example, that we want to take just the vertices, for example, the number 0, that is the one in the crown, or maybe another one, for example, the number 3, the number 6. I always forget that, I'm sorry. The list item is in the Sets tab. The list item can be found in the list group, and you can see a lot of different components that, for example, lets us subtract an element, split element. It's a lot of data that for now we're just starting to select one. Finally, we have the last one, and let's work with these 3 elements. We need to place 2 BReps and a curve. In this case, we place this BRep, maybe copy and paste it, and also a curve. Let's set each one and also set the curve. And now let's play with the BRep curve components. You can find it in the physical group. Here you can find the BRep curve component. Let's place it. And for example, let's connect one BRep, that is the one that we're selecting. Let's, for example, hide this so we can see only the elements placed in Grasshopper. I'm just hiding and selecting only isolating this element that is apart from the model. We connect this BRep to the BRep input and this curve to the curve input. And we can see, for example, that he's giving us just the 2 points of the intersection between them. Let's add another one. Let's add a BRep that can be found here in the physical group. Let's place it, and let's place with the first BRep and in the second one. You can see, for example, here when we select it, that he's showing us just the curve result of the intersection between the both BReps. And finally, let's add a trim with BRep that is in the region group. Let's connect it. Let's add, for example, this BRep to the BRep input and this curve to the curve input. Here you can see that nothing happened, but it's because he's showing the result from the inside and the outside too. So this curve was separated, was trimmed by the BRep, but he's showing both results. In this case, we can add a line component here in the geometry, and you can connect it, for example, in the inside out. And you can see he's showing us just the region of the line, just the line that was inside that BRep, and also in the outside input. You can see that he's showing us In this case, for example, we can see, let's copy and paste this line. You can see, for example, that he's showing us a thinner line, that he shows us one curve, but in this one is a thicker one, a double one. And this is trying to show us that it's a list of curves. So it's a more complex data that we're processing here. You can see that these are two curves, and in this case, it's just one curve. So that was it. We have learned a lot of the interface and the group of components that work in Grasshopper. We're going to continue getting deeper in that with other groups and other tabs in the next two videos. So I will see you on the next one.